Assalamu alaikum warahmatullahi wabarakatuh. So today is our lecture 19, and in this lecture we will continue our chapter discrete and variables. So the topic for today lecture is averages, and expected value. So averages and expected value. So averages from the statistics, the most commonly used averages we know are the mean, median, and the mode. Mean actually gives you the is the sum of numbers, is the sum of numbers in a series divided by the number of data items. Median gives us the middle of the data set, and the mode gives us the most repeated value in the data set. So let's look at one simple example to understand these basic concept. So this is actually example 3.23. So in this example it says that suppose we have the test grades of 10 students, so from 0 to 10. So we have these 9, 5, 10, 8, 4, 7, 5, 5, 8, 10. So the first thing that we need to calculate, say, is the mean. Mean is the sum of these numbers: 9 plus 5 plus 10 plus 8 plus 4 plus 7 plus 5 plus 5 plus 8 plus 7, and divided by 10. So this comes out to be 6.8. Now the median. So median can be found out here for this data set to be it is 7. So median here is 7 since there are 4 grades above the 7 and 4 grades below the 7, and the mode is the most repeated grade. So we can see that 5 is repeated 3 times, so 5 is the mode. So 5 is the mode of the data. Now the next thing that we want to know about it, this is very basically basics of statistics. So as we want to apply these concepts to the discrete random variables. So starting with the definition of the mode. So mode says that mode of a random variable, x is a number, x mod satisfying p x mod that is greater than p x of x for all x. So what it simply means that mode is the value of x with highest probability. So mode, in simple words, we can say that mode is a value of x with highest probability. So this is the mode. Median is defined as a median x median of random variable x is a number that satisfies probability of x is less than or equal to x median, that is should be greater than 1/2, and probability of x is greater than or equal to x median, that should be greater than 1/2. So we have to fulfill these two conditions for the median. So let's look at a very simple example to understand this basic concept before going to the finding the mean of these discrete random variable. So let's take an example. So it says that if we have x and its corresponding PMF values, say it is 1, 2, 3, 4, 5. So the corresponding probabilities given in their PMF are 0.2, 0.3, 0.1, 0.1, 0.3 and 0.3. So the mode will be here with the highest probability. So because we have two numbers which are having the higher same probability as 0.3, and that is the highest probability. So this data has 4 and 5. So it is actually a multimodal data, multimodal discrete random variable, we can say. Now to find out the median, that is a bit tricky here. So for that we need to actually use the cumulative probability cumulative distribution. So for that we need to calculate Px is less than or equal to x, which is we know it is the definition of cumulative distribution cumulative distribution function. So that we calculate. So for that we need to calculate 0.2 with the previous probability, which is 0.2. So 0 plus 0.2 is 0.2, and that would be added with 0.1, it would be 0.3, and then it would be added to 0.1, it would be 0.4, it would be added to this here 0.7, and it will be added to 0.3, it is 1.0. So that is the cumulative probability distribution. So by definition median for would be the average of, or the mean value of two numbers here, and these two numbers can be chosen as, say, x1 is equal to the largest value of x, the largest value of x, such that probability of x, that's what we have written here. Now x1 is less than or equal to 0.5, and x2 is equal to the smallest value of x, such that Px is less than or equal to x2, is greater than or equal to 0.5. So how we can choose these numbers? So let's move here, and so for x1 that should be less than 0.5. So less than 0.5 we will start from here, because we are looking for x is less than or equal to x1, so we will start from here. So where it is less than 0.5, so we will stop here, so we will take this number as x1. Now for x2, so that is the for such that x1 is less than or equal is greater than 0.5. So greater than 0.5 we will move here, and before reaching 0.5 we will see which number we get. So for, it is 0.7, after that it is 0.4, so we will take this number as x2. So median will be then 3 plus 4 divided by 2, which is 3.5. So this 3.5 signifies that our probabilities will be the middle of the probabilities will be 3.5. So most of the all the probabilities will be divided into 0.5 and 0.5, which will means at around 3.5. So above that is probabilities will be around 3.5, and below 3.5 the probabilities will also be around 0.5. So as we can see here, up till the x1 we have 0.4, and up till here we have 0.6 obviously. So in the middle 3.5 we will be approximately close to the probabilities which have the values of 0.5. Now the mean of the random variable, discrete random variable, it is actually defined as the expected value. It is defined as the expected value of a random variable, expected value of a random variable, and which is a very significant number that we use in the random variables, and it's mostly used to visualize the data and to predict whatever predict certain number of things about the data that we are looking into, or the probabilities that we are looking into the discrete random variables. So the expected value of x, the expected value of x is simply a function written as e of x, which is can be written as mu sub x, and it is defined as the summation over the range of x, x times the probability mass function of x. So that's actually quite simple to find out this number. So it sometimes you will see it is called the expectation or expected value. Sometimes people use the term mean value, but mostly we use the mean value for the statistical or the experimental data that we get, and we take the mean of, just like we have seen in the previous example. So let's look at the example to see how we can calculate this expected value, and how it is a mean of a random variable. Example 3.24. So it says that we have this PMF given, Px of x. So it is 1 by 4 for x equal to 0, 1 by 2 for x equal to 1, 1 by 4 for x equal to 2, 0 otherwise. So we can also plot this. So we have 0, 1, 2, say 1 by 4, 1 by 2. So 1 by 4, 1 by 2, and 1 by 2, 1 by 4. So the expected value of x, which is mu of x, is actually defined as summation over the range of x, x times Px of x. So what's the range of this random variable? 0, 1, 2. That is, this is the range of this random variable. So for this example, we can first open this summation x, which is actually 0 times this x0 p x of 0 plus 1 times px of 1 and 2 times px of x. So this would be obviously 0 times 1 by 4 plus 1 times 1 by 2 plus 2 times 1 by 4. So obviously this would be simply 0 and this would be 1 by 2 and this will be just 1 by 2. So the expected value or the mean is 1. So remember that expected value of x is not the probability, so it could be any number between with any real number. So we don't have to worry about that. If it is 1 here, that was so that could be greater than 1 even, because it's just a mean value of the random variable. In the previous lectures we have seen the families of discrete random variables, and we have discussed that different experiments can be represented by any one of the family that closely fits them. So what's the benefit of that? One of the benefit that we have seen was they have the same mathematical model, and that can be used for different experiments with just a different small change in the variables. But there is another benefit of that we can have these expected value of the families of discrete random variables are very well defined. So we don't have to calculate them, we don't have to calculate all these values for the families of discrete random variable. So I will just tabulate all of those here, so it would be easy for us to remember. So first we have seen the Bernoulli random variable. Bernoulli random variable and the expected value of these families of random variables. So we don't need to prove them how they come, but you just if you want to do some proofs, they are given in the book. So expected value of x for Bernoulli random variable is p, and for geometric p random variable, its expected value is 1 over p. Similarly, the Poisson random variable, Poisson alpha random variable has the expected value alpha. So the binomial NP has the expected value simply n times p. And for Pascal, that we had seen, Pascal k p, we have the expected value as k over p. And for uniform discrete random variable or discrete uniform KL random variable, it is simply k plus L by 2. So this is the expected value of these discrete random variables. Now let's look at the example to understand all these basic concepts. So let's copy this from the book. So it's quiz 3.5. It says that in a pay-as-you-go cell phone plan, the cost of sending an SMS text message is 10 cents and the cost of receiving a text is 5 cents. For a certain subscriber, the probability of sending a text is 1 by 3 and the probability of receiving a text is 2 by 3. So let's see. Equal the cost in cents of the text message and find. So this is a very simple. It says that we have a cell phone company which are charging 10 cents for sending the text and 5 cents for receiving the text, and the probability of sending the text is 1 by 3 and the probability of receiving the text is 2 by 3. So the first thing is we need to calculate the PMF. So PMF will be simply PC of C. So for 5 cents it is for receiving. The probability of receiving is 2 by 3. So it will be 2 by 3 for C is equal to 5 and 1 by 3 for C is equal to 10, and to complete this 0 otherwise. So remember that we usually write this PMF with increasing number of the range of the random variable. So the next it says the expected value of C. So expected value of C is simply summation of over the range of this C random this random variable C times PC of C. So that would be simply because the range here is simply S of C is simply 5 10. So it will be 5 times 2 by 3, 5 times 2 by 3 plus 10 times 1 by 3, 10 times 1 by 3. So it is actually 20 by 3. So which is 6.67 cents. So this is the average cost of sending and receiving a text message over this cellular phone company. So the third part says the probability that the subscriber receives 4 texts before sending a text. Now for this part we have to think it about Bernoulli trials, and we say that the trial is success. So see, we will solve it. The trial is success if subscriber sends a text with the probability P is equal to 1 by 3, and we say that let R denote the number of text, let R denotes the number of text received before sending a text, number of texts received before sending a text. So we can say that R could be R is the number of failures before the first success. So R is then similar to geometric random variable, except R is equal to 0 is possible if the first text is sent rather than received. So in general we can write this PMF very simply as the geometric random variable. So it would be P R of R. So it is 1 minus P R times P. R is equal to 0, 1, 2 and so on, 0 otherwise. So the probability of receiving 4 texts, so the probability of receiving 4 texts before sending a text is P, probability of R4, which is equal to 1 minus P, or 4 times P. So for P is equal to 1 by 3, it would be simply 0.066. So the next part, it says that the expected number of texts received by the subscriber before the subscriber sends a text. So it means that we have to find the expected value according to the part C. So the part D is R is, we know that geometric P, and for geometric P, if we just go back 1 or 2 pages, so where we have written this table, so it is simply geometric P has the probability of 1 over P. So we don't have to go through all the steps, because for like this, so we will just go and say that expected value of R is simply 1 over P, and 1 over P is 1 by 3, so 1 over 1 by 3 is, so 3 is our expected value of this random variable. So we will stop here inshallah, and we will just continue this chapter in the next lecture. So stay blessed. Assalamu alaikum wa rahmatullahi wa barakatuh.